Let us analyze few sinusoidal functions and then understand how they are being transformed. So the question before us is, explain how the following functions are related. A, B, and C, we are given three sinusoidal functions. The first one is y equals to sine 2 of x plus 30. The second one is sine 2 x minus 30. And the last one is sine 2x minus 30. How are they related? Well, all of them are sine functions and their k values are same, which is 2. That makes their time period to be same also, right? So time period for each of them is 360 divided by 2, right? So in these functions, what we have is, we can say time period t is equals to 360 degrees divided by 2, and that is 180 degrees. That is the time period, right? But how are they different? They're different because of this number here, right? That is the difference between all three of them, and that is because of phase shift, right? So that is the difference. Phase shift is sinusoidal function starts from which point, or the maximum shifts by 30 degrees, in this case left or right. That is what you need to decide. So we'll try to analyze this part. So definitely these are same sine functions with a change in their phase shift. Now let's analyze phase shift for each one of them. Now in the very first case, which is sine 2 x plus 30 degrees, time period is 180 and the phase shift is 30 degrees to left, right? So it is minus 30. That means 30 degrees left. In the second case, it is x minus 30 within the bracket. So when x is equals to 30, in that case it will be sine 0, or the value of the function will be 0, right? So it is plus 30. The phase shift is plus 30, and that means 30 degrees right. So horizontally, this wave is 30 degrees right, right? So it is effectively 60 degrees right of the previous one. Now let's look into this one. This is kind of typical. Now here you'll find that we have within bracket 2x minus 30. Now to find out exactly what is the phase shift, we need to factor this number 2. And once we factor, we can write this as sine of within bracket 2 x. When you factor this out, you have to divide this by 2. So you get minus 15. Do you understand? 30. So this means is shifted by 15 degrees to right. So that is 15 degrees right, not 30. So that is the difference when we write this 2 inside the brackets or outside the brackets. So that is a good point which you should note, right? Now when you sketch these functions, so basically how are they going to look like? So let me sketch each one of them here to show that we can appreciate the difference between them, right? Now in the first case, the sine wave actually starts earlier, minus 30. Do you see that? That is earlier shifting left by 30 degrees, right? So that is what it means. Now, so I'm just doing an approximate graph here. So, you know, like this kind of. That is what it means. So it started at minus 30. That is the starting point. So it starts at minus 30. That is how the function should be, right? And the time period is 180, and therefore it ends at 150 degrees. That is one full cycle. Now for the next one, it starts after 30 degrees. So the first cycle actually starts from here, 30 degrees, right? And so it starts at 30 degrees. So it will end at 180 plus 30. So this point will be 180 plus 30, which is 210 degrees for you. Right? And of course, in each case, maximum will be 1, minimum will be minus 1. Right? So that is how they are similar. Amplitudes, axes, they are all same. Now in the last case, the time period is 180, but it starts after 15 degrees. So the last case will be kind of like this. So that means it will start at 15 degrees, right? And end at 180 plus 15, so 195 degrees. So that is how they are related, and that is how you should understand them. Now with this kind of knowledge, let's move on and do transformation of sinusoidal functions. I hope you appreciate it. Thank you.